Good morning, boys. This is the fourth chapter which I am going to start. Earlier we have finished three chapters: linear inequation, banking, and factor theorem and remainder theorem. Matrix is the fourth chapter which I am going to start. This chapter is very new for you. You have not studied anything about this chapter. So, what is matrix? What is the definition of matrix? What are the terms related to matrix? Types of matrix? Many things are there which you need to know before starting the exercise. So, I'm going to start with the first, what is a matrix? See, this is a horizontal line. This is second horizontal line. And this one is first vertical line and this is second vertical line. So, horizontal line number 1, horizontal line number 2, vertical line number 1, vertical line number 2. If you see properly, both the lines are intersecting each other at a point. So this is point of intersection of horizontal line and vertical line. So in this way, we are getting 4 points of intersections at a time when we have taken 2 horizontal lines and 2 vertical lines. So what to do with these 4 intersection points? So take any number, there is no restriction about the number. So suppose I have taken 7 for the first point, 8 for the second, 5 for this point, and 4 for this point. So wherever these horizontal and vertical lines are intersecting each other, we have used few numbers, and I used those numbers like this only. Now just ignore these vertical and horizontal lines. So these lines are ignored now. We have left with the numbers only. So I am writing it number clearly. 5, 4, it was 8, and it was 7. So we have arranged the numbers in horizontal and vertical formats, and after arranging these numbers, enclose them in a square bracket and give the name of the whole representation by any capital letter. So this representation of number is called matrix. So what is the final definition? Matrix is the arrangement of any number in horizontal and vertical lines. Enclosed those numbers in square brackets, and the name of this arrangement will be given by capital letter. So this is called a matrix A. Correct? Now, in the simple language, it was horizontal line number 1. In matrix format, it is called row number 1. This is row number 2. This is column number 1, and this one is called column number 2. So how many rows and how many columns are there? We have 2 rows and 2 columns. Correct? In this way, we can use different horizontal lines and different vertical lines. It means we can get different rows and different columns. So it is not necessary to have only 2 rows or 2 columns. But remember, in our syllabus, we can use maximum 2 rows, maximum 2 columns. That's why I have started with our maximum rows and maximum columns according to the syllabus. Alright? Now, how many minimum rows and minimum columns can be used? And how many maximum rows and columns can be used? That I am going to explain it through the example. So, see the second example. Minimum 1 horizontal line, minimum 1 vertical line. So how many point of intersection will be there? Only 1. So take any number. Ignore these lines. Enclose it in the square bracket. So horizontal line will be called as row number 1. Vertical line number 1 will be called as column number 1. So total how many rows and how many columns are there? 1 row and 1 column. This is the smallest matrix which is possible. Means a matrix can have minimum 1 row and 1 column. Correct? See, 1 row, 1 column, the value of this product is 1, and this one represents how many numbers you are used in the matrix. See, this is the number, not the value. So 1 number has been used. Actually, the number used inside the matrix is called element of the matrix. So the number of rows 1, number of column 1, the product of these numbers is 1. It means how many elements will be there in this matrix, that is 1. Alright, so we have minimum smallest matrix whose name is 1. Now the second important part, number of rows are 1, number of rows are 1, so number of rows by number of column. This will give you the information about the number of rows and number of columns. So this presentation which give you the information about the number of rows and number of columns is called order of the matrix. So smallest matrix can have the order 1 by 1. This is read as 1 by 1. The first represents the number of rows, second represents the number of columns. Row will be first. This is the writing pattern. Row will be the first, column will be the second. So the number of rows by number of columns together is called the matrix, order of the matrix, and when you multiply them, this represents the number of elements of matrix. Correct? Another example. So that will help you to understand again the order, the number of elements and the different matrices. I have taken a matrix over here. Directly I am writing the matrix like this: 4, 7, now we have to find how many horizontal lines and how many vertical lines are used. See, horizontal line 1, vertical line 2. If horizontal line is 1, so number of rows is 1. If vertical lines are 2, means columns are 2. So it is a matrix of order number of row by number of column, that is 1 by 2. So when you write the number of rows and number of columns separately in this format, that will be the order of the matrix, and when you multiply them, that becomes number of elements. Correct? Another example. Name of the matrix is C. 1, 7, 4, 3, 5, 9. We have to find how many rows and how many columns are there. So very simple. Horizontal line number 1. So that will be row number 1. Horizontal line number 2 means number of rows are, this is the number, row number 2. Vertical line number 1 will be column number 1. Vertical line number 2 will be column number 2. Vertical line number 3 will be column number 3. So how many rows are there? 2 rows. And how many columns are there? 3 columns. So what will be the order of the matrix? 2 number of rows by number of columns. Multiply them, it is 6. So that 6 is called number of elements. So how many elements are used? 1, 2, 3, 4, 5, 6. It is 6. Correct? So this is another matrix. Go for the last example. I'm going to take quite large matrix, and the matrix is D. 1, 5, 7, 9, 11, 12, 0, 3, -1, 6, 9, 11, 5, 2, 3, -6. We have to find the number of rows and number of columns. So very simple. Again the same pattern. Row number 1, because this is the horizontal line number 1. Horizontal line number 2. So row number 2. Number 3. So number 3, R3. R4. So how many rows are there? 4. How many columns are there? That we have to find. Vertical line number 1. So column number 1. Vertical line number 2. Column number 2. Vertical line number 3. Column number 3. Vertical line number 4. Column number 4. So how many rows and how many columns? 4 rows, 4 columns. So order is 4 rows by 4 columns. Number of elements is 16. Count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So total 16 elements are there. Order 4 by 4. So in this video I have given you the definition of matrix, order of matrix, and number of elements of a matrix. So I am going to repeat it again. Matrix is the arrangement of any number in horizontal and vertical forms, or matrix is the arrangement of rectangular arrangement of any number. So horizontal arrangements, that horizontal lines are called rows, vertical lines are called columns. Number of rows by number of columns is order. When you multiply them, you will get the number of elements. Correct? Okay. So now we have come to the situation where I have to represent the matrix in the better way. Alright? So better way means what? Row number 1 row number 2, column number 1, column number 2. These are the point of intersection of rows and columns, means where we have to put the elements. So instead of going for a particular value, I am going to use a symbol, and that symbols will help you a lot during solving the exercise. See, what is the pattern of deciding the symbol of every place where we need the element. Now, while writing the order, we follow the pattern of number of rows by number of column. Number of rows by number of column. The row will be first, column will be second. Matrix is A. So symbol of the element I am taking as A. Correct? A is a part of row number 1 and column number 1. Row number 1, column number 1. So the symbol of the element is A11. The first suffix indicates the row and the second number indicates the column. Alright? This is row number 1. A, row number 1, but it is a part of column number 2. So the symbol becomes 1, 2. Alright? Okay. So here the symbol of this element is 1, 2, A12. A is the general symbol. This part is important, which indicates the location of the element. This is the element of first row and second column. So the two symbols are ready. Go for the third symbol. This row number 2 but column number 1. So the symbol will be A21. What about this? Row number 2, column number 2. A22. Ignore all these horizontal and vertical lines. Enclose them in a square bracket. This is the mathematical representation of a matrix. Here, at the right to the bottom, we represent the order of the matrix. So A is a matrix of order 2 by 2. And these are the symbols of the matrices, elements. Alright? So every element having 2 digits as a suffix which represents the location of that element directly. Suppose we got an element whose symbol is B53. What does it mean? It means this element is the part of fifth row and third column. Fifth row and third column. Correct? If we have an element D with D37, means this element is a part of third row and seventh column. Okay. So the symbol of the matrix that I have discussed over here is A11, A12, A21, A22 with order 2 by 2. This is the row number 1. Can you see? This is row number 2. So 2 are there. This is column number 1. See the column 1, 1. This is the column number 2. See the 2. How many rows are there? 2. How many columns are there? 2. Generalize it. Suppose we have m rows and n columns. So the number of rows are m, number of columns are n. So how the representation of the matrix will be there? See. Finally, we are generalizing the representation. A11, A12, A13. So they all are the part of first row. So the first suffix remains same. Column number 1, this is column number 2, this is column number 3. So row number is fixed, columns are different. So how many columns we have decided to take? So in the previous example I have taken as number of rows m, number of columns n. So how many columns are there? N. So 1, 2, 3, 4, 5, 6. The last column will be n because this is the first row. So the first suffix remains same. Second suffix represents the column. So every element has different column. So this is the last column, that is n. This is the first column, that is 1. Now this is the second row, beginning of the second row 2, but the column number 1, so 2 1, 2 2, 2 3 and so on, 2n. Then column number 3, sorry, row number 3, but column number 1. Last column will be n and so on. This is column number 1. So see, 1 is same everywhere. The rows are changed. How many rows are there? So starting with 1, minimum 2, 3, 4, 5, 6. How many rows are there? M. So here we have to finish it with number of row M, but the column is 1 only. You move along with this, it will be M2, M3, and the last is Mn. Correct? Enclose them in a square bracket. Give them a name of matrix A. So this is the generalized and the largest matrix. What is the order? Number of rows are M, number of columns are N, so order is M by N. But the biggest problem is this big matrix is not easy to write again and again. So how to write it in the simplest form or smallest form, or we can say compact form. So here is the symbol of writing this matrix in compact form. Now, name of the matrix is A. The elements are written in the square bracket. It's very true. And this consists so many elements. And every element has some suffix. Every suffix has two parts, first and second. Correct? The symbol of the matrix element is A. Every element has some suffix. Every suffix has two parts. So the part number 1 I, part number 2 is J. Correct? And at the bottom, right bottom, we have to write the order of the matrix. Now, what is I and J? I is ith row. How many rows are there? M. So minimum row 1, maximum row n, means this is the value of I. So this is the minimum value of I and this is the maximum value of I, means the value of I is less than or equal to M but greater than or equal to 1. This is J, means jth column, second part of the suffix. Minimum J 1, maximum J n. So the limitation of J is J will be less than or equal to n but greater than or equal to 1. So this is the compact form of the matrix. Correct? So please go through the video, revise it very properly, then only you will come to know the topics of the second video. Thank you.